All right, we're going to start with homework number 20, and we've called this rational exponents. And although we'll get into rational exponents, the beginning of this lesson is a continuation of the last lesson where we were talking about binomial radical expressions. And the directions for the first set of problems ask me to multiply each pair of, and it uses this word, conjugates, right? And what's a conjugate? So conjugates have the same terms, binomials with the same terms, but opposite operations. So like you can have like a plus b times a minus b. Notice that the a's are the same, the b's are the same, but then you have an opposite operation in the middle, okay? So you have the same terms, a, and then b, and then the opposite operation. Okay, those are conjugates. So the directions have asked me to multiply each pair of conjugates. So for number 1, I have the quantity of square root of 5 minus the square root of 11 times the quantity of the square root of 5 plus the square root of 11. All right, now this is a binomial, and we can multiply binomials together via the box method. All right, so I'm going to go ahead and draw my box. We've used the box method before, so this should come to no surprise to you how we do this. I'm writing the square root of 5 minus square root of 11 or across the top, and then I have the square root of 5 and the square root of 11. All right, square root of 5 times square root of 5 gives me 5. The square root of 5 times the square root of, or negative square root of 11, that will give me negative 55. Okay, 5 times 11 is 55. And then I'll have positive 55 because 5 times 11 is 55. And then I have negative 11 times square root of 11 times negative square root of 11, which will give me a negative 1. Okay, when I add up everything that's inside, I'm sorry, this would be negative 11, or negative 1, negative 11. I have 11 and then multiplying them together, keeping that negative sign there. I'm going to add up everything that was inside the box. So I'll say plus the square root of 55 minus the square root of 55 minus 11. All right. These will cancel out when you subtract the square root of 55 minus the square root of 55. That gives you 0. So 5 minus 11 gives me negative 6. And that's my answer. Okay? And notice that when we multiply these conjugates together, that middle term will end up canceling out because it's the same exact number and you're just subtracting it. So we'll see that again in number 2, where we have the square root of 3 plus the square root of 5 times the square root of 3 minus the square root of 5. Okay, so once again, we're going to draw our box for the box method. Okay, I have the square root of 3 plus the square root of 5, square root of 3 minus the square root of 5. The square root of 3 times square root of 3 gives me 3. Square root of 3 times square root of 5 gives me the square root of 15. The square root of 5 times square root of 3 gives me the negative square root of 15. And the square root of 5 times the negative square root of 5 gives me negative 5. Okay, because if I just had the square root of 5 times the square root of 5, I would get 5, but the negative out in front makes it negative 5. Okay, I'm going to go ahead and add everything up that I see. 3 plus the square root of 15 minus square root of 15. See how those are going to cancel out, right? I'm going to go ahead and cancel them out. 3 minus 5 equals negative 2. And my answer to 2 is -2. All right, so when you multiply conjugates together, you're going to end up getting rid of that middle term there. We'll go ahead and add a new layer. We'll get that close. All right, so we're moving on to rational exponents now. And the first bit asks me to simplify each expression. And it gives me 36 to the power of 1/2. Okay, we've dealt with exponents before, but what do we do when we have a number raised to a fraction as an exponent? So what you would do is whatever is actually in the numerator versus whatever is in the denominator. Think of it split up like that. So you have the numerator up top here, the denominator on the bottom. So the denominator is going to end up being, well, I guess I'll draw it below here. The denominator is going to end up being the index, and the numerator is going to be whatever power that's raised to, or the exponent. Okay, so for example, if I were to rewrite this, I can actually rewrite this using a radical, and this is the same exact thing. 36 raised to the 1/2 power is the same thing as writing the square root of 36 to the first power. Okay, and we really don't even need that 1 there because anything to the first power is just itself, right? And the square root of 36 would be 6. So 6 is actually my answer. So 36 to the power of 1/2 is the same exact thing as the square root of 36. Okay, so when you have a 1 up above there, that's going to be the power, and 36 to the first power is just 36. 9 to the first power is 9. X to the first power is x. All right, so if we move on to number 4, number 4 is 27 to the 1/3 power, right? And when you rewrite this, once again, remember the index of the radical is going to be 3, okay? And what's out in front there is going to end up being the radicand. And if you raise to the first power, once again, anything to the first power is itself. So the cube root of 27 equals 3. 3 times 3 times 3 is 27. All right, simple enough. Number 5. All right, number 5, we have 2 to the 1/2 times 32 to the 1/2. Right? Now, I could easily rewrite this as the square root of 2 times the square root of 32. And then the square root of 2 times the square root of 32 will give me the square root of 64. And the square root of 64 is 8. And that's my answer. All right, so that's just an introduction there. And now we're going to go the other way, okay? Actually, I'm sorry, this is going to be using x now. So if I have number 6, it says write each expression in radical form. So we're going to go ahead and write x to the 1/6 power. Writing it in radical form would include me including my radical symbol, right? So if I were to write that in radical form, I could just write the 6th root of x, and that would be my answer. All right. Number 7, I have x to the 1/5 power. Remember that whatever's in the denominator here is going to end up being the index when I switch over to radical form. So I could write this as x, or the 5th root of x. And with number 8, Number 8 is x to 2/7. All right, so now taking a look at this, remember that the 7 denominator is going to be my index, and then I have x to the 2nd power. The reason why we didn't just include like to the 1st power in there is because anything to the 1st power is itself, and you can simplify it even more. So our answer here for number 8 would be the 7th root of x squared. All right, and that's number 8. All right, so we have been moving back and forth between exponential form and radical form. All right, so we were starting off in exponential form, and we were then writing the expression in radical form, but now we're going to take ones that are in radical form, and we're going to write them in exponential form. All right, and we're going to do this pretty frequently, but I'm going to go ahead with number 9 and get started. And I have the cube root of x squared, okay? And remember that when I write this, whatever's in the denominator will be my index, and whatever's in my numerator will end up being the power that I raise it to. All right, so my index is going to end up being the denominator, and the power that I raised it to was 2. So it's the same thing. X to the 2/3 power is the same as saying the cube root of x squared. So this would be my answer. All right, and then number 10. Number 10 is the 4th root of x to the 3rd power. Okay? And the way I'd write this is I'd write what's my variable there, x, and I would take whatever the index is, make that the denominator, and the numerator is whatever powers it's raised to. So my answer would be x to the 3/4. All right, and that's number 10. Number 11, let's move on. Number 11 asks me to simplify each number, okay? So if I'm looking at number 11, I have 8 to the 2/3. So now I'm taking everything that I've learned so far and putting all those pieces together, okay? I know that I can write this as the cube root of 8 squared, okay? And if I'm simplifying this, as it asks me to do, 8 squared, what's inside, imagine the radical as like inside parentheses, because if we're using PEMDAS, parentheses, and then exponents are the second, so we're going to use exponents, and we're going to rewrite this as 8 squared, which is 64, okay? And the cube root of 64 is 4. So 4 is going to be my answer. Okay. Number 12. Number 12, I have 4 to the power of 3/2. All right. So rewriting this, I'm going to have the square root of 4 to the 3rd power. All right. And that would give me 4 to the 3rd power. 4 times 4 is 16 times 4 is 64, right? So the square root of 64. 8 times 8 is 64, so the square root of 64 is 8. And that's my answer. All right, last one. We're going to be on number 13. All right, and 13 is 16 raised to the power of 3/2. All right. And in writing this, I can write this as the square root of 16 to the 3rd power, all right? And 16 to the 3rd power is actually 4,096. 16 times 16 times 16. It's a bigger number, okay? And then if we find the square root of 4,096, we end up getting 64. So our answer to number 13 is going to be 64. All right, so we've been moving back and forth between exponential form and radical form and looking at these exponents. Really, once again, whenever you see whatever's in the numerator, that's going to be the power that's going to be inside the radicand. And whatever the index is, whatever's in the denominator, is going to end up being the index. So we're going to be moving back and forth between exponential form and radical form pretty often. Okay, so being able to just work with this consistently, and this lesson was just introducing what we're going to build upon in future lessons. But that is homework number 20, rational exponents. Let me know if you have any questions.